Hi, this is Javin Kharod, a chemical engineer by profession, going to conduct today's lecture, alkylation unit. Now, what is that? An alkylation unit is one of the conversion process used in petroleum refinery. It is used to convert isobutane and low molecular weight alkane, primary mixture of propane and butane, into alkylate, a high octane gasoline component. The process occurs the presence of acid such as sulfuric acid, hydrofluoric acid, and depending on the acid used, the unit is called sulfuric acid alkylation unit or hydrofluoric acid alkylation unit. In short, we are defined as SSAU and HFAU. The alkyl produce high quality gasoline blending stock by combining two shorter hydrocarbon molecules into longer chain gasoline range molecule by mixing isobutane with a light olefin such as propylene or butylene from the refinery fluid catalytic cracking in the presence of acid catalyst. Since crude oil contain 10 to 40% hydrocarbon constitute in the gasoline range, refinery typically use fluid catalytic cracking unit to convert high molecular weight hydrocarbon into smaller and more volatile compound which then converted in the gasoline size hydrocarbon byproduct. Fluid catalytic cracking process also include other lower molecular weight alkane and isoparaffin molecule which are not desirable. Alkylation transform the byproduct in the larger isoparaffin molecule with high octane number. The product of the unit alkylate composed mixture high octane branch chain paraffinic hydrocarbon mostly isooctane alkylation is the premium gasoline blending stock because exceptional anti-knock property and clean burning. Octane number of alkylate depend mainly kind of alkane used upon operating condition. For example, isooctane result combined butylene and isobutane which has octane rating 100 by definition. These are product alkylate effluent. However, octane rating will vary accordingly. Now catalyst. Suitable catalyst also important factor decide whether build alkylation plant. Sulfuric acid. Now sulfuric acid alkyl significant volume of acid are used. Exist suitable plant required supply of fresh acid and deposition of spent acid. Construction sulfuric acid plant significant support alkylation unit and significant impact both initial requirement, capital and ongoing cost operation. Now, possible to process unit to regenerate the spent acid, no drying of gas take place, which means no loss of acid, no acidic waste material, no heat is lost in the process, gas reheating. The selective condensation of the condenser and the regenerated fresh acid will be 98% weight. Even humid process gas, it is possible. Combine spent acid regeneration, disposal hydrogen sulfide by using hydrogen sulfide as a fuel. Now, hydrofluoric acid. Hydrofluoric acid alkylation unit required less acid than the sulfuric acid, achieve same volume of alkylate. Now, hydrofluoric process are only create small amount organofluorine side product. They are continuous remove reactor and consume hydrogen fluoride replenish. Hydrogen fluoride alkyl unit are capable processing wider range light and feedstock with propylene, butylene and produce alkylate with higher octane rating sulfuric plant. However, extreme caution required working around hydrofluoric acid due to hazardous nature. Acid is produced very few location and transportation straight manage and regulate. Now solid acid. Research area solid catalyst alkylation ongoing many years. Numerous patents exist different catalysts, catalyst support and process Lewis acid catalyze alkylation reaction. Alkylation isobutane olefin discovered using aluminum chloride promoted with HCl. Several of current preferred solid catalysts use either boron trifluoride and antimony pentafluoride. Since alkylation process produce heavy polymer, solid catalysts have tendency for quickly, therefore solid catalyst process have two major hurdles of overcome: catalyst life and catalyst regeneration. Now ionic liquid and alternative HF and H2SO4 of the alkylation catalyst. Ionic liquid, they are salt that have melting point 100 degrees centigrade. It exhibits strong acid property, so they can use acid catalyst. Without using conventional liquid acid, ionic liquid are the salt in liquid state composed of the ion convert C4 paraffin, other olefin, excellent gasoline range, pending product. Olefin feed and alkylation unit generally originate from fluid catalytic cracking unit contain butane, isobutane, possibly propane and amine. Their olefin feed also like to contain such propane and butane and pentane. Non-condensable such as ethane and hydrogen and contaminant dilute in principle have no effect reaction. Alkylation occur proportion of the reactor and can influence yield secondary reaction, polymerization and the undesired organofluorine side product. Incondensable chemical perspective are the dilutant but do not condense at pressure and temperature of the process. Therefore, concentrate point that must be vented. Contaminant are compound, react dilute sulfuric acid catalyst, increase acid consumption and contribute produce undesirable reaction product, increase polymerization formation. Common contaminant are water, methanol and ethanol. Catalyst, proponent, alkyl, propane butane to produce reactive carbocation which alkylate isobutane. The reaction carried out mild temperature and two-phase reaction. Because reaction exothermic, cooling is needed. Plant require lower temperature. Cooling medium need chilled. Normal refinery cooling water suffix. It is important to keep a higher ratio isobutane alkane point of reaction to prevent side reaction which produce lower octane product. Plant have high recycle isobutane back to feed. Phase separate spontaneously. Acid phase is vigorously mixed. Hydrocarbon phase creates sufficient contact surface. Unfortunate, a number of secondary reactions take place and reduce quality of the alkylate effluent. Polymerization result from the addition second olefin carbocation and form the primary reaction with resulting C12 carbocation can continue with react olefin to form larger carbocation. As the previously described mechanism, heavy carbocation may undergo hydride transfer of the isobutane to yield C12 to C16 isoparaffin and tributyl cation, which heavy molecule tend to lower octane and rise boiling point of the alkylate effluent. Now, hydrofluoric acid alkylation unit can divide into two main sections: reaction, fractionation and defluorination and aluminum treating. Purpose of unit: react olefin feed isobutane and reaction section presents HF hydrofluoric acting catalyst to produce alkylate. Now prior enter the reaction section. Olefin and isobutane feed are treated closer to remove water, sulfur and other contaminants. Temperature 60 to 100 degree Fahrenheit, 16 to 38 degrees centigrade, which is convenient, does not require refrigeration and sufficient pressure is maintained so that components are liquid state. In the fractionation section, alkylate is separate from excess isobutane and acid catalyst distillation. Unreacted isobutane recovered, recycled back to reaction section and mix olefin feed. Propane is major product to distillation process. Some of amount N-butane enter the feed and also withdrawal side product. Propane and butane have separate from the treated olefin pass the unit all through. They do not participate directly reaction and adversely impact product quality. They provide avenue of the organic fluoride and lower the limit. The propane stream is removed, tower cooled, HF stripper and then process defluorination section remove combined fluoride and trace acid may be present into mist operation. Many units of remove butane and typical get treated separate the defluorination section. The sulfuric acid alkylation unit divide into 5 major sections. In this section of the reacting hydrocarbon, olefin feed, both fresh feed and recycled isobutane. Recycle through contact with sulfuric acid, catalyst under controlled condition and temperature 60 degree Fahrenheit means 15.6 degree centigrade. Feed are treated, remove impurity, especially water, in order to reduce corrosion. Heat of reaction is removed, refrigeration section and light hydrocarbon are purged from unit. Effluent treating section, free acid, alkyl sulfate and dialkyl sulfate removed from the net effluent stream, avoid downstream corrosion and fouling from settler. Sulfuric acid present in the reaction zone, so catalyst, alkylation reaction. Theoretically, catalyst promote a chemical reaction without change the result of reaction. However, acid is dilute as a result side reaction and feed contaminant. To maintain desired spent acid strength, a small amount fresh acid continuously charged acid recycle line in acid settler reactor equipment amount the spent acid withdrawal acid settler fractional section unreacted isobutane recovered recycle reaction remaining hydrocarbon are separate into desired product. The spent acid degas in the acid blowdown drum where pH adjusted and acid vent stream are neutralized, caustic and scrubber before being fired, going to storage and periodically removed. Now, operating variable isobutane concentration. Second one is temperature. Third one acid strength. Fourth one olefin space velocity. Fifth one mixing. And in the refinery, examine, however, makes sense economically. The alkylation unit are complex, economy of scale, and they are comparable. Capital investment cost, SSAU and HFAU are, not surprisingly, how two processes are competitive capital cost basis. Consider basic process difference. SSAU has more expensive reactor section required refrigeration. However, equal costs are realized. HF unit are needed for feed design, product treating, regeneration equipment, and more exotic metallurgy. Addition, most refiner will require dedicated cooling system and remove risk site-wide corrosion. HF leak the capital cost and equipment due to the possible hazardous aerosol formation. HF catalyst either release superheated liquid, expensive mitigation system required many locations throughout the world. HF use alkylation system. Now alkylation unit. Primary process hazard. The unit process large volume of hydrocarbon which are highly flammable potential explosive and acid catalyst, corrosive and toxic. Both SSAU and HFAU similar volume of hydrocarbon, the similar risk associated with each acid are quite different. HF required much stricter precaution because of its greater potential harm and due to its low boiling point, higher harmful potential, light of higher risk because of low boiling point, spent HF regenerated by fractionation and HF alkylation unit. However, fresh HF must be still brought in the refinery, replace HF consumed, the unloading and handling fresh must be undertaken with great care. Since this operation, some risk refinery worker, surrounding community, HF release, previous discussed perhaps the greatest transportation risk related HF is the potential release during an accident while transporting fresh acid and manufacture refinery mitigation equipment would available accident site. Thus consequences would be catastrophic. Okay guys, this is up to our today's topic alkylation unit. I hope you get sufficient knowledge after watching this video. Next Sunday, we have covered some another chemical engineering topic. Till then, goodbye. Do take good care of yourself.